Hi there. So we're going to be working through a problem involving the titration of a weak acid with a strong base. We've got 50 milliliters of 0.1 molar HC2H3O2. We're given its Ka, and we're told that we're going to titrate it with 0.1 molar NaOH. Calculate the pH after different volumes of titrant have been added, and then use the results to plot a titration curve. So we can see we've got a series of problems here to do. So the first thing I'm going to think about is writing a balanced equation, and we start every titration problem with a balanced equation. So let's see here how I can do that. I've got my acid, and I've got my strong base, and I know it's a double replacement. Here is my plus and my minus, my plus and my minus. All right, and I can see it's a 1-to-1 ratio. So if I use the information that I'm given in the problem for the acid, I've got 50 milliliters. I'm going to go ahead and convert that to liters of 0.1 molar of that, and I'm titrating it with 0.1 molar of this. Where it's a 1-to-1 ratio, I can see that I can reason out that there'd be equal molar at the same volume. So at neutralization point, I should have 0.05 liters of NaOH. And so when I'm looking at the questions that I'm asked, I can see that that's one of the points right there. So I'm going to be able to figure that out. And you know, I've written this as a reaction that goes to completion, but it's not, because this is a weak acid strong base. So we're going to have kind of an equilibrium at times here. So let's get started. When we have 0 NaOH added, we'll do that first. 0 milliliters of NaOH. We just have the acid. So I'm going to set up an ice table. I'm going to write my acid in its generic form here. And say I've got 0.1 molar to start, and no H plus or A minus to start. My change is going to be minus X here, plus X here, plus X here. Therefore, at equilibrium, I have these values. Oops. Glad I have an eraser. And I can then write my equilibrium expression as the concentration of H plus over A minus over the concentration of HA, and I have a value for that. I was given in the problem 1.8 times 10 to the minus 5. So if I substitute in the values that I've got here at equilibrium, I can see I've got x squared over 0.1 minus x equals 1.8 times 10 to the minus 5th. I can assume that 0.1 minus x is approximately equal to 0.1. Because this value is so small, any change is going to be very small in comparison to the initial concentration. So when I solve that, I can rewrite it as x squared over 0.1 equal to 1.8 times 10 to the minus 5. X is 0.00134. I'm remembering that X here is my H plus concentration. But what I'm looking for is pH. So pH is the negative log of H plus. So the negative log of that concentration. And therefore my pH is 2.87. That's in the case, the first line here, I'm going to fill that in, 2.87.